docs. So this is actually the second time I'm talking about Groovy and Jenkins, and the first one was in 2014 at the Jenkins user group meeting that happened in Boston. I don't know if any of you attended. I was probably the most odd presentation of all, because they were close to, I would say, 400 developers at that meeting, and they all were talking about DevOps operations and so on, and I was the only one that was talking about high content screening. And if you don't understand what high content screening is, don't worry about it. We'll talk about it a little bit. But it's been an interesting road, and actually last month I met with the Jenkins creator, who happened to be in Boston, and was looking for some groups to meet with to see what people were doing in the arena of Groovy. And I said to him, I would love to meet with you, but I'm not doing any DevOps stuff. And immediately he goes back and says, I want to meet with you because I'm interested in other stuff. I hear about DevOps all the day, and I just really want to know what's happening in other places. So we had an interesting couple hours discussion last month, and if you go to the Biono blog site, you can read a little bit about it there. But may as it be, who am I? I'm a research scientist at a local pharmaceutical company here. I do have a master's in software engineering. I'm an open source advocate, and I contribute to a couple different projects like the Biono that we'll talk about a little bit more extensively, and Jenkins as well. I have taught graduate level classes at Brandeis, and I'm currently actually teaching a Groovy class at my workplace. I do blog occasionally, and I do love crafts, and I'm getting into Arduino and Raspberry Pi as of lately, so that should be fun. So here is a kind of an outline of what I would like to talk about today. Please, if you want to ask questions, do so. Don't wait for the end. And we'll try to make this interactive and relaxing and fun. So I'll talk a little bit about what I do and how I do these things, what I think makes Jenkins attractive for life science use. I'll talk a little bit about the Biono project, how Jenkins integrates into a life science high-performance computing environment. And on the title of this talk, Groovy and Jenkins, I'll talk about some of the fundamentals of how Groovy integrates in Jenkins, the modes of operation, security, plugins and uses, and Groovy scriptlets, which is a particular type of Groovy code in Jenkins that can be used everywhere, essentially, that Jenkins can do things. And hopefully I'll be able to give you some examples that you can do, perhaps if you're using Jenkins even in a very generic way, how we use Jenkins as an artifact repository, creating consistent build reports, and also creating some interactive Jenkins interfaces with a new plugin that the Biono project has contributed to Jenkins. So before I make too many assumptions, how many of you know what Jenkins is? Okay, so there are a couple that never heard of Jenkins, perhaps. And you know what? This is probably the exception in the crowd. If I was to ask the same question at work, they all point to my boss, whose name is Jeremy Jenkins, and they say, you made some software, you named it after your boss. And I said, well, that's good for performance evaluation time, but no, that's not the case. So we'll talk a little bit about what Jenkins is. But before we do that, I just want to give you an idea and a little bit of a warm-up thinking. I hope the sound works. But this is one of my colleagues, and last year they made a little video about the work they're doing, and I'm going to play this video. It's only about 3 minutes short, and because I want you to get a feeling to the type of things that I'm dealing with sort of day to day, and the kind of problems I'm trying to address with these things that we're talking about tonight. Okay, let's see if the sound works. Only from here, huh? Is there a sound?
I don't think there is.
No.
Hold on, let me see if I can get this all the way up. And maybe it'll work.
My name's Elaine Donahue and I work in the high throughput screening group here at Novartis. High throughput screening is just a quick way to basically screen a biological reaction against a large number of compounds. In the very early days of drug discovery, in order to find a compound or look for a drug, it was really sheer luck. But now with the existence of high throughput screening, we're able to identify molecules that are active on particular targets or pathways of interest much more quickly to give us starting points for drug discovery. We couldn't do our job without the automation. The automation allows us to consistently and rapidly run these assays against our compound library. Our compound library is probably well over 2 million compounds at this point, and in the high throughput screening group, we screen about 1.6 million of those compounds through each of the targets of interest that come into our group. It used to be to run each test that you had to hand pipette into each well to run each reaction. Now with the new instrumentation, we have things that will, in the same time that you're pipetting into one well, can dispense into an entire plate and enable us to go from running 30, 40 samples a day, and now we're running up to hundreds of thousands of samples per day. What used to take months and years, we can now do in days and weeks. The robots allow us to run the assays around the clock. They allow us to run the assays in a very consistent manner. Sample 1 on the first plate is treated the exact same as the last sample on the last plate. To do this kind of process manually, you would never have such consistent data results. I think the most significant challenge with high throughput screening is the vast amount of data that we're generating now. When we used to generate 100 data points per day or even less, we're now generating 150,000 data points per day and sometimes even more. But then what to do with that data, that's where the scientists play a role. I think the main benefits for using high throughput screening drug discovery is the speed at which you can get to a drug. I think the motivation for all of this is to find something that can help a patient. And back in the day, it was a very slow process to get there. And now that we've enabled high throughput screening, we get a lot closer to starting points for drugs. We get there a lot faster than we used to.
So you saw the robots that are setting up these assays. And in fact, I brought one of those assay plates with me for you guys to take a look if you've never looked at a plate with these assays. In fact, probably what Elaine was showing you was an earlier version of these plates. I'm going to pass this around, but essentially what you're going to see is a matrix of 1,536 wells. Okay, and you're well aware of those. Right, this is a special plate. As you see, it's black. The reason for it is because we don't want any extraneous light to come through. The bottom is glass, and so you can put it on the microscope, and you can take pictures of cells that are grown at the bottom of these plates. So you can look at it, pass it around. On the side, it has a barcode that allows the robots to pick these things up and know what they're doing, what the orientation is, and so on. But essentially, what we're dealing with is individual cells that are grown at the bottom of these wells. And if you think about it, a cell is the smallest intact reaction vessel that we can have in doing chemistry, in biochemistry in this case, right? So taking these cells and treating them with various chemical compounds, Elaine was talking about 3 million different compounds is the chemical libraries that most pharmaceutical companies, including Novartis, have access to. Essentially, these are different structures, some of them made in the lab, some of them are actually found in nature. And all of those are becoming the building blocks and the starting points for drug discovery, for finding new medicines. And when you're dealing with that, you want a way to screen through those and find the ones that are important in the type of disease or biological pathway that you're looking at. And the cell seems to be the most sort of convenient and intact way of looking at what's happening with all of the molecules that exist in nature. So how do we actually do these reactions and how do we monitor them? Basically, you grow the cells at the bottom of these discs and you treat them with thousands of compounds. I'm wondering if I lost my connection. Let's continue with this for the time being. And you come and you take cellular images of these from the bottom of these plates. And some of these images may look like what you see here. And perhaps the kind of interesting biological response you may be looking for is the movement of these green stain, which is a particular receptor, a biological receptor that triggers a biological response from the cytoplasm of the cell, which is this green area around the nuclei, back into the nucleus. A lot of these proteins that we're looking at act by turning on and off genes, and in order to do that, they got to get into the nucleus and do this. So this is the kind of response you might want to analyze with image analysis. So you'd be taking some of these images. Some of them would be from controls that you have treated with some compounds. You know they have the biological effect you're looking at. Some perhaps from materials that do not. And you'll be looking for, through your library of millions of compounds, to see if you can find some similar response. So while we're working with these kind of things in the lab, the idea is to develop infrastructure to process large numbers of cellular images and imaging pipelines for identifying and quantifying these image features. And importantly, we want to develop user-friendly software that the scientists in the lab can actually use. A lot of what is happening here, it has immediate relevance to how a scientist in the lab has either set up the assay or they understand what the biological pathways in the particular assay they're doing are. And therefore, they are the ones that are responsible for reviewing the data to know if there's some artifact or if there's some response that is important. And that actually is taking us into some new mathematical analysis area now. It's called multi-parametric data analysis. Because as you can imagine, looking at image analysis, you're getting multiple readouts out of these images. We can tell something about the location of the stain. We can tell something about the size of the cells. We can tell something about the number of the cells that are appearing, perhaps some compounds, such that those would be looking for cancer treatment, for example, that would be killing some of these cells, or this is the kind of thing that you would be looking at. So you are collecting multiple parameters out of these assays, and we're entering this area where it's called multi-parametric data analysis. Some of these measurements may be correlated, some may be not, and we want to find relationships and eventually develop machine learning methods that are able to look at this data and tell us what of these compounds are doing. So when you're looking at the output from these so-called high-content screening analysis, you're looking at thousands of images. One of these plates that is showing you typically would generate 3,000 plus images. The reason being these plates are imaged in multiple wavelengths. They are stained with multiple stains. Some of them fluoresce at one particular wavelength and some at another. So you take multiple pictures in your automated microscopes that allow you to tell several things. The image that was showing you before only had one stain, right? But the image that we saw earlier, for example, over here, has multiple stains. There's a blue for the nucleus, red for some other structure, and then green, right? So for each one of them, you would need to take actually a separate picture, which just the camera detects as a grayscale, and then overlap them to create the images. So you can imagine sort of the volume of the data that we're generating here. If you look at the process the data analysis process, basically it is divided into three major categories. The one is the acquisition of the data, the image processing that turns the images into numbers for these various features, and finally sort of the data analysis that involves QC and what we call the hit identification. So pretty much on a daily basis, I use a set of tools that deal with these major parts of the workflow that I showed you. Image analysis, we use an open source software from Harvard called Cell Profiler. There are a number of other tools that I use as well. For data analysis, many of you may be familiar with R, which is sort of the granddaddy of all of the statistical analysis packages and languages. Of course, Python is another major one now. For scripting and workflow, a lot of the scripting happening in Groovy and Jenkins, and we use the local cluster that we have at Novartis, which has about 4,000 nodes, in order to be able to scale up the image processing and the data analysis. So how do we get here? How do we get from DevOps, where Jenkins is, to life sciences? So let's start by talking a little bit about what Jenkins is used for, and that should fill in the gap for the few of you that still don't know perhaps what Jenkins is. Jenkins is a continuous integration tool. Continuous integration has been part of software development for several years now, and essentially is a best practice approach where as soon as you write new code and you check it into a code repository, that code gets checked out, compiled, run against a number of tests, and immediately the DevOps team knows whether your code is good, whether something that you introduced broke something else, or things are still working, and therefore you can go ahead and start doing deployments or things like that. Right? So there is this sort of cycle of where Jenkins, which is these open source continuous integration server that started at Sun, and now after Sun was sold to Oracle, of course, it's an independent project. But basically, you watch the code, you build the product, you run tests, and you publish the results. Okay? And there are thousands and thousands of DevOps teams that are using Jenkins. There are entire Jenkins farms. Jenkins can use a master-slave kind of architecture to scale up. Some of these builds could take actually literally days to happen. Right? So you want to have a very robust and scalable tool, and Jenkins is one of them. So what's that leap of faith you need to make in order to say, okay, well, if Jenkins is doing these things, how can we get to life science applications? So from the workflow I showed you earlier, you can start imagining this very similar workflow where we're watching for new data coming out of the instruments. We are doing data QC. We run analysis and we publish results. All right. So if you're sitting in that interface between science and computers and software development, you can see those things. And the challenge is for a lot of us that are either on one side or another to sort of see both sides, right? So tried to publish a paper on this, and he went to a bioinformatics journal, and people said, there's nothing new here. There's an open source software that you're using, and another open source because we're trying to publish the integration between Jenkins and Cell Profiler, the image analysis software. So you have not discovered anything, and the paper got rejected. So I don't claim any fame or money in all of this. Okay, so. By the same token, when I came to talk to developers, they don't quite sometimes get sort of the reason we so much love Jenkins because it can do those things. So Jenkins is free and open source software. It's platform independent. It's written in Java. It runs basically anywhere, and it integrates with any other language, right? I'm going to talk about specifically about Groovy tonight, but it does integrate with Python, with R. We're using in all of those things, mainly because Groovy is such a wonderful glue that can bind these things together, and it has direct access into the Jenkins API. It's modular and expandable. There are over 1,000 plugins that the community has contributed, and is really well supported. Okay. A Jenkins server as a life science server can provide a web portal for a variety of utilities and tools you may be developing for your users. Your users do not have to install. It came to me when I was developing some Groovy scripts I wanted people in the lab to use, and everybody needed to install Java, then install Groovy, then learn how to get to the command line and write some of these things, and then I can actually provide a user interface now. People can run any of those scripts through a user interface that provides a much better support for running it, and you don't need to install Groovy on your computer. And we'll show how you do that. So, importantly, in science right now, one of the big topics is reproducibility. Okay? There is a whole topic about reproducible research. How do we take data and reproducibly process it, or if we take the same data set, can we reapply the same analytical tools and come to the same result? So, Jenkins is very good at that. It can act as a data management platform and also as a collaboration platform. Anyone sort of, you can define access criteria for your Jenkins server, and people, can go there, look at other people's data and analysis, which is important for us, right? It works pretty well as a collaboration platform. They can see if somebody else has analyzed the same data, so they don't need to redo it, and so on. Interestingly, you can link these individual so-called build steps that Jenkins does together to create pipelines. And this is an example of a pipeline that runs on my Jenkins, and it essentially launches Solid Profiler on the nodes in the cluster. And until we were able to do that, there was only like a couple people in the group that they were able to, knew how to write a Q sub script that they could submit to the cluster and, chunk the data the right way so that you had all these nodes, processing images and so on. And after we wrote this Jenkins pipeline, now anyone from the lab, once they get their data, they can go there and basically with a couple clicks, they can launch a Solid Profiler run on the cluster. And so, you can monitor the success or failure of these runs when they were interrupted. In this particular case, this was interrupted over here. This was successful to the end. So let's see how Jenkins integrates in this high-performance computing environment. Jenkins has a very well a very stable project format. Okay, when you go to configure a Jenkins project, you will see a number of different sections that are the same across every project. So you have, of course, metadata around the project, then parameters that are maybe required in order for you to do your particular build, triggers. In most of our cases, the triggers are manual triggers that are user triggers because they usually interact with the data. They select data sets they want to analyze or parameters they want to put. But a lot of these triggers in most DevOps operations are automatic. For example, a checkout from the code repository, right? Or a change in the code, or a new file in a folder can trigger a build. So there's a lot of different triggers. The environment in terms of supplying additional properties. And then it's sort of the meats and potatoes of a build. It's a series of build steps, and that's where the plugins that Jenkins has contribute into the build. You can pick up a module that, for example, will copy files. You know, they're very modular and they are very granular, right? Something else might be just that it launches an SSH command on a remote cluster, or that it runs a Groovy script, right? So all of these plugins contribute now to the build steps, and also you can configure a number of post-build actions, which is very similar to the kind of things that you may need to do. You may need to clean up some files, you may need to merge some files together, or do some QC, whatever it is that you may be able to do. So this box here basically represents what Jenkins does pretty much out of the box, or with installation of some plugins that you will easily install. The SSH plugin essentially is what allows us to go out to the cluster and very easily trigger remote scripts, remote applications, and self-profiling in this particular case, and some specific data sharing infrastructure allows us to share what most of the instruments are mapped on Windows drives or shared drives where they deposit the data. But of course, on the Linux cluster, we need to have read-write access to the same things. So these instrument data shares also shared and mapped onto the Linux cluster. So that allows us very quickly, without copying or moving data around, just with pointers to work and get the images that we need, deposit the output of those imaging analysis runs where they could be used later on. Okay, so Groovy. How is integrated in Jenkins and what can we do with it? The most basic thing is the Groovy plugin. It's like any other plugin that exists. You can install it, and once you have it, you can include now Groovy scripts in your build and post-build steps. Now there are two modes that which Groovy runs in Jenkins. The one is what's called a system Groovy script, which runs in the same JVM as Jenkins, and it has access to all of the internal object network that Jenkins creates when it starts, or it can run in a forked JVM, so you will not bring down Jenkins, if something happens, and it is a little bit more work to bring in the environment perhaps that it will need to work with, and we're going to show how that works. Let me try again to see if I have access to the network. I'm wondering if it needs a refresh from time to time, you think? And it does not. Let's see.
Sounds like you've got it.
Okay, I've got that. It's just maybe the
Is your VPN still connected? No.
it did. Time out maybe. Okay. So this is what a running instance of Jenkins looks like. It's really, and that's one of the beauty. Right now I'm actually, as I told you, I'm teaching a bunch of scientists Groovy, and in fact they want to learn how to do also the integration in Jenkins. And everybody went and downloaded an instance of Jenkins on their laptops, and they can run it off their laptop. It's just as simple as what I'm going to show you in a second. So basically, you can go to the Jenkins site and download Jenkins, and then actually let's go to the desktop. So right? All I did was to download the Jenkins WAR file, okay? And basically create a Jenkins shortcut, or actually we can see immediately how it works. Okay, as simple as that, somebody has an instance of Jenkins running on their laptop. Okay, so Jenkins is fully up and running. At this point, you can go to your browser and say the default port is 8080. And here we are at Jenkins, okay? I just created this instance like half an hour before I left, so there's not that much there, but I just wanted to show you how easy it is to set it up, okay? So now, if you were interested in installing the Groovy plugin, basically you need to go to Manage Jenkins. There's a special section here for managing plugins. You can go to the available. The only perhaps tricky thing is to set up the proxy of your server so that it finds, you know, the internet. I did this before I left work. So these are all the plugins that exist for Jenkins, somewhat loosely categorized, but if you type Groovy here, it will come up with a number of scripts that, plugins that have Groovy in here. And basically we want this, and maybe the post built, and my favorite scriptlet, and active choices, which is we're going to talk about, and you can install. So it goes, downloads these scripts and these plugins, and installs them. So that's just in terms of demo. I'm going to go back here for a minute and show you that once you do that, now you can go to Manage Jenkins, and you will have access to something called the script console. And you can start typing arbitrary Groovy scripts there that you should be able to run. And the result is hello world. Okay. Okay, so already you could actually have something that runs Groovy, and the user doesn't have to install anything if you want. But of course, the script console is not designed to be facing a user. It's mainly for administrative purposes, for people to do, various cleanup jobs or reviewing Jenkins jobs and so on.
What would happen if you type system.exit? Would it kill the JVM that's running?
Probably. Dot?
Exit. Exit 0.
Is it? Doesn't it?
0? Do you have to?
Actually, let's don't do it on that server. Yeah, I was thinking that was actually the server that was that I just started.
Yeah,
But that's not.
no, that's the real one.
Yeah, that's the real one. Let's don't do that. Also, let's don't do delete dot star dot star. Okay. So, do you have a Jenkins server or what? Okay.
We'll try that.
Let me know what happens. We'll add it to the notes of this. Okay.
So close.
Very good. So close. Anything else you want me to try? Embezzlement? Was that part of your training? So, okay. Let's go back to the presentation for a minute.
Quick question before you move
Yeah.
on. Is Groovy bundled with the plugin, or do you have to have that installed?
Good, very good question. You can install. Actually, let's go back to the instance we just started, which installed these things. Once you go to manage Jenkins, you have two options. You have the option to either, if you have already Jenkins Groovy installed, you can use your own Groovy instance, or you can have it download and install Groovy internally. So over here on the configure system, let's see, under tools. Okay. See it there.
It's in global tool configuration.
Is that it? Yeah. Thank you. Right. So this is where you can add your own JDK and your own Groovy here. And I think by you can name it you can give it a name and then install it from here.
You just click apply.
Apply. Yep. So it's pretty easy in general. Although obviously I didn't remember it. It's not something you do it once you get your server up, and I know it's there. Just don't remember. Thank you for putting it up though. All right. So, right, and a lot of the discussion that we're having with Koshuki, who is the Jenkins creator, when he was here talking to us, actually had to do with some concerns that I'm raising the way we're using Groovy in Jenkins, especially with the Active Choices plugin, because it allows you to run Groovy scripts, allows you to inject JavaScript into your user interface, and it could be dangerous, right? So some of those things have already addressed now, to the extent that you can have your plugin, and now Active Choices does the same thing as we'll talk about, be dependent on the script security plugin. So essentially there are two ways that you can allow scripts to run. The one is where you can have a script and allow a global approval that is approved by the admin. And the other one is a sandboxing approach. Basically, you can whitelist and blacklist methods that are called from your Groovy script. And this is usually done through the plugin, that essentially they will allow or block Groovy from doing certain things. All right, so if you look now if you sold Groovy, now you are opening yourself up to other plugins that are able to use Groovy, the Groovy plugin. And some of those are the ones that are dealing with the user interface. We're able to do things now with active choices like this, where you get dynamic and cascading parameters, which was not something that was available in Jenkins before. So you can select a parameter here, it updates a related parameter. All of that is done with Groovy. And then there's, of course, plugins that deal with how Groovy can be used as a build step. You can execute a Groovy script. You can write your own scriptlet. We'll talk about those. And finally, the Pipeline Groovy plugin is a big and upcoming tool in Jenkins community. I will show you a very quick slide at the end. All right, so let's say that you have some Groovy scripts that you're using, that they're processing some data, or that they're doing some important function. I'm going to take you through a number of pragmatic slides now on how you can take any script essentially that you have and adapt it so that it can be used through Jenkins. All right. So here I have a script that I was using for doing merging of CSV files. Okay, those are very frequently encountered, comma-separated value format. This is what I call an advanced merge because it does quite a few things. So some of the parameters is we have, we can have a different delimiter that you can pass into the script, where the file of the join data will be stored. A filter that you can apply to the CSV files, and it will only select a subset of those. If you want to if you have a mixture of names and only certain needs to be, and a few other things, right? And kind of fancy things like there are people that they had data that are stored in a named folder, but then the file itself, all the files themselves have the same name, right? So imagine data coming from 10 of those plates, and each one has a barcoded folder, the name of the barcode in the folder, and then the data itself is called image CSV. So all of them are called image CSV, but it's the folder in which they exist that gives the discrimination, right? And now when you want to merge it, actually you want to have an additional column that has the name of the folder there, so that you can when you look at the merged data, you know what folder they came from. So that's the extra metadata, right? File meta that you can include, and so on. So it's a pretty complicated script, lots of parameters to set up and so on to run it. Basically, this is I'm giving you a recipe that you can use with any other script that you have in order to make this script run from a UI in Jenkins. So this is a command line interface script. Users will be able to run it remotely through a web UI. Okay, and here is the web form for building this. Okay, they can annotate it. Here's the source folder. Here's the file filter that they can type in. There's another folder filter that they can type in. It allows them to have sometimes the CSVs are not that greatly formatted. They have like 2 header rows, and we allow them to select how many header rows. They can click off if they want to add these metadata coming from the folders as extra columns. They can choose the delimiter from a drop-down list. Okay. The important thing here is that these are parameters that they see in the UI, and these are actually the parameters that Jenkins will pass to the environment of the build. So when you are ready to write sort of this adapter script, the first thing that you do is you read in the environment of the build, and you assign these these parameters to from the environment variables that are similarly named. Okay, and now you can give them the same sort of designation as you have in your command line interface script. Okay, so we call them S, F, P, and so on, which was these names right here, right? Is a lot of designation for the options. Importantly, some of them actually take parameters, some don't. So you can have an option that is without a parameter, right? So for example, the M parameter, the M option, is just basically, do you want me to include file metadata, right? It doesn't have any more information. If you include the -M, a -M on the command line, it will do it, right? So basically what we do is we can take all of these, build a list, an argument list here, and format them and validate them, and then call the script, the original script that you had, and pass in that argument list like this. Okay, so this is the main script, the main method of the script, of the Groovy script, when it gets compiled. And then this is essentially the parameter list that you passed in through Jenkins. And this is sort of the little helper method that formats it or validates or does all kinds of things. So this is the same code that you can use with anything else. Right? And you can adapt essentially any kind of script to run from a Jenkins user interface. The only other thing that you will also need is to add, so here's the name of that script. It's a script that runs in a forked JVM, and you need to pass in the class path of the original script so it knows where it is. Okay? So just a little code here and a configuration of a class path over here. It allows you to run essentially any script from a UI. Any questions?
But how do you generate the forms in the UI that map to?
So the forms in the UI actually, it's not that difficult, but I will show you some of the way that you do that, okay? So let's say that we create a new project in Jenkins. It's going to be a freestyle project. This allows us to put parameters in there. And once we click this build is parameterized, it allows us to add parameters. All right, and this is where you have all kinds of choices of parameters. So we're to look at this, and we wanted to kind of like simulate what this looks like. You know, we have a build name and a source folder. Both of them are simple strings. You can add some description, which will be very useful for your user.
While you're doing that, can I ask, was there between a string parameter and a text parameter?
Yeah, text can have carries, returns, and so on, so you can have actually
A block.
a block of text. Okay, just for the fun of it, I'm going to add one of my favorites, because we're going to talk about this. I'm going to add an active choice parameter, and that is now going to generate dynamic options for us. Okay. And we're going to do it from the Groovy script. It's as simple as saying return So here's our user interface, a drop-down box. Of course, there's nothing to build, but submitted to the cluster. I want to to the Jenkins server. I want to show you the fact that we have now captured those build parameters, and you can view them. And here they are, right? So, you know, you have a record of them, how you did an analysis of parameters you use, and so on. So that's how you eventually built, you know, your user interface, right? There are all of these types of parameters that you can use, and it's pretty straightforward. It's really not that difficult. You had a question?
I was going to say, can you put a map into that place you put your list for names, pop map in there? So
Yes.
select
So
Grails.
the active choice parameters accepts a map or a list, and so you can see a human readable value while you're passing in some code or something like that, right? So we can do something like my bigger monitors because I can actually see. Yeah. So now when we pass in, we see still the same human readable things, right? Or we got B. Okay. All right, so one of my favorite plugins is the Scriptler plugin. Not only allows usage of Groovy scripts, but essentially it allows you to create a managed script catalog within Jenkins itself. And then you can choose your scripts. They're already there. There's some annotation around them, and you can use them. In addition, when you first start, you can get to the remote script catalog, which is already pre-populated with a few dozen scripts that are mostly DevOps oriented. But if that's what you're doing, they will be quite useful for you. They're ready to use them. Basically, you install them into your own system. Okay, this is how you configure a Jenkins scriptlet. Basically, you define you give some metadata annotation at the beginning, some comments, the name of the Groovy script file. You allow permissions to run the script. And then basically you pass in parameters and you write your script code. All right, and we can look actually at this script code right here. Okay, what does this do? This is a scriptlet that allows me to identify the file type of files that users are uploading to the server. depending on what the file type is, I may do some different processing on those files. Okay? So you're welcome to look at the code. If you really want to look at this in action, I'll take you to one of the projects here. Where it says upload any file. So this is one of my utilities that allows me to upload not only tabular data, but pictures, presentations to the server and annotate them a little bit. Sometimes I have large data sets that don't go through the email, and I need to share them with people. So I'll upload them to the Jenkins server and just give them the link to the artifact, and they can go and download them from there, right? So, you can see a few different options here, but basically over here, the file content right now, it just says choose a file, right? So once I choose a file, right, let's say I do in fact choose a CSV file. It immediately this updates now to CSV table. Interestingly, it also allows the user to override this. So if the user says, you know what, I gave the CSV extension, but in fact this was a tab separated file, right? They can still override it. And that's important for us. All right, if you give it, let's say a PDF file, it will tell us it's a binary. Okay, so you selected that by default. Suppose it has a PDF option here. I don't know why I didn't pick that one. It has to be that sort of the type of thing that is behind this. So if we want to look at how this is configured, do you want to stop for a break? Or do you
Yeah, it might be a good time. to
Okay,
stop.
so let me finish with the script letter and then we'll have a little break. How about that? Okay, so this is how you would configure it when you have scriptler catalog populated. So the file content parameter is driven by a scriptler script. It's an active choice parameter. This is the catalog of the scripts, right? So I chose the ones as the helper for detecting the file type. The parameter that I need to pass in basically is the name of these parameters up here. The my file parameter, okay? Which is it's called a file parameter, and it shows up on Jenkins as a button for upload. Once you upload, that parameter gets populated, and so the script itself can process it and figure out what type of file it has. Useful reports. You're analyzing data, you're collecting all kinds of files onto your Jenkins server, and you want to have a quick way for your users or yourself to be able to get some feedback. The first sort of piece of advice is generate metadata about your data. Okay? So, for example, working a lot with numerical data, that come from these instruments, this analysis. What I was showing here a minute ago was, and I guess I closed it, is after a particular analysis, we create a high-level metadata summary of the file itself in order to be able to, for the user to be able to, with a quick glance, know what's happening, right? So looking at this data set here, right, we can see, the mean, standard deviation, median of the values. This file itself has how many data points? 1535 rows of data, okay? And so this is actually a metadata table that we're creating for this data set. Right, and we distill it down to, a column, a row per column that gives us some of the statistical distribution of the data. It tells us if some rows are missing, some data are missing. And so this at a glance is a quick way for a user to get feedback on their data, their process, are things working or not. So for most of our analysis, we create these reports, and I'm going to show you now how you create actually these reports in a kind of a quick and easy way. Okay? So there is something like this. These reports are tabular. They are, you can split out various aspects of your, of what you want to show in different tabs. You can include lots of graphics. These are some heat maps of these plates, right? That basically represent the values that came out for each one of these parameters in one of these wells, right? We can, click and see these in more detail and so on. Right? These are, by the way, they're generated from R, but we can present them in these reports. All right, so this is what we're going to talk about now. How do you build these reports in a relatively easy and straightforward manner, right? So here's what's happening under the covers. You're doing a Jenkins build, and what that generates is so-called build artifacts. Your data files, your metadata, whatever else you're going to generate from it, okay? There is a very nice plugin called a summary report plugin that generates these types of reports. The only problem with that is that you actually need to supply it with the report in an XML format. When you open one of these reports, it looks kind of like HTML, but it's in an XML format. It's structured well, but if you were trying to do this every time, it would be a pain, right? So what I try to do is say, okay, you know what? I do this hundreds of times. I can't deal with writing a specific XML report every time. I want to program that out, right? So I wrote this small script, which is available on the GitHub, and we'll look at it. And I said, you know what? All I need is a small report configuration file that just tells me what I want in the report. I don't care, how to make it. I just, you tell me, I want these tabs, I want this information, or I don't want that information, so I'm able to filter something out or do this kind of thing, right? And so this is how it works. During the build, we're creating these artifacts, the data, the metadata, and so on. Then this Groovy write XML scriptler that we have takes the build artifact as an input and the report configuration and writes this report XML file programmatically. I never have again to worry about this. Okay? By the same token, from there on, the summary report takes this file and creates this report. Okay? And it's pretty smart. If it's missing data, it will skip the tab rather than blow up, or if it doesn't find something correctly, it tries to be very sort of forgiving and still create something. So as you see here, this is an example report configuration. Not that complicated. It's basically a set of key value pairs. Okay? And basically the data that can come into these reports, that can come in from either key value pair property files or any other kind of delimited file, including CSV files. And we can show them either as you saw before, as tables, like this, or as key value pairs like this, right? So the report itself, basically, it tells us how to represent these things, okay? So first of all, you see here tab header. These are the headers I want in my tabs. If I have key value pairs, I want the keys in black and the fields in values in blue. That's telling me something about the report colors and layouts. If you have a large table, you probably just want to show a snippet to the user. We do that all the time. Some of these tables are thousands of rows long, right? So basically, there is a max range of data to display. That you can say, you're only going to show like 10 rows or 20 rows so that the user gets an idea of what the thing is. If they want to see it, they got to download and put it in Spotfire or Excel or whatever and look at it. Then importantly, we're defining the data sources. Where is the data that's going to come into each one of these tabs? So as you see here, each tab over here, the name of each tab, becomes now a key differentiator where the content comes. So the content of the parameters tab is going to be a table. The table data is going to be coming from this param props file, CSV, and the header for that is going to be just these 5 columns of the original CSV. So we can restrict the number of data both vertically in terms of the columns we want to show, as well as we'll show you in a minute in terms of the what we can filter out of you can show a filtered set of data. Right, so we can define data selectors for the columns, the rows, and the properties. So that's basically the report configuration. That's all you need to do. For every new report that you're going to create, you create a configuration that you add what kind of tabs you're going to show, where the data is going to come in, how much you want to show. Yeah.
Can this data source be coming from a relational database?
Not right now. Yeah, and the reason is dealing with data that was presumably created from the build itself, right? You could presumably have as part of the build step, a query into your database that exports the data, puts into the build, and then you can show it.
So that's the metadata. Mostly you're building reports from the metadata.
Yeah.
Got it.
Yeah. Any other questions? Okay, so that's sort of examples of the reports. This is another example. By the way, these reports are they can be sorted by clicking on the top, so that you can mix graphics and this actions tab is always something that I put on my reports. Basically, it's kind of a breadcrumb from my users to say, now that you are at this stage, here's the kind of things that you can do next. Okay? So, especially since these are pretty complicated analysis that, they have multiple options of what to do with the data next, right? They can put it into some sort of multi-parametric data analysis, they can do some QC and so on. So, when I generate these reports, I always have a little actions tab. It's almost like, kind of a cheap way of creating a workflow where I tell them, what to do next with the data. And here is another type of report with lots of R graphics that can be. So how are the R graphics going in? All you need to do is in your file that you're writing out is to write the URL for that file, for that picture. Okay, and when the report is generated, if it hits a URL, it will create an image. I'm sorry, if it hits a URL with an image as the target of that URL, it will create a picture. If it hits a URL that is not an image, it will just create a link. So, we, for example, put links for downloads of the data. See these links over here? Or in this particular, it's not downloading, but it's for another link. So if you have a CSV file and one of the fields is a URL, it will either create a link or create a picture, depending on what the URL leads to. So all of that happens automatically for you. All right, so this is actually the last part where we're going to talk about building a dynamic UI using the active choices a little bit. It's not, the Groovy is used essentially to return either a list or a map, or the interesting thing is return formatted HTML. Okay? When you do that, actually, you can write JavaScript in that HTML. And when you do that, all of a sudden now the Jenkins UI becomes much more interactive. Just using yes. So here is the simplest case of how to use these active choice parameters. Right? Basically, these are the kind of things that Jenkins did not have before, and that is cascading parameters. Right? I'm changing the folder here, and I see a list of files in that folder. Okay, dynamically. So that's the first thing that the active choices does. It has two types of parameters, actually three types of parameters. The one is called an active choice, and it's just returning a it runs Groovy and it returns a list or a map, and you can create a selection UI control. It can be a drop-down list, it can be combo boxes, I'm sorry, not combo boxes, check boxes, or radio buttons. The one that takes actually as an input the name of the other of another parameter or more in your UI, and as those change, it gets updated. So those are cascading parameters that allow you to do these kind of user interaction. All right, so for example, here I have a data set, I select it, here's the metadata essentially for it, I select any of it and I can see it over here and review it. Okay, so all of that, or we can also filter them for you too. All right, a lot of these examples are actually on the Active Choices plugin wiki for Jenkins. So this is the Jenkins Active Choices plugin. It has a pretty good uptake. I don't know how many of you are looking at these metrics ever, but we've only been out for about a year and a half, so it has pretty good uptake. There's a whole bunch of examples. I try to animate them. This is an example where you're using formatted HTML to change the picture depending on whether you choose male or female, for example, here. Okay, you can filter these things. So there's pretty good documentation on the wiki site. And so these are some of the options on how you can represent these things as number lists, as this is the formatted HTML option. And the original idea was that we're going to use these to give you some feedback on a parameter that you just chosen, right? So as you see here, as we choose from our wine menu, is making some suggestions around the type of wine you might want to choose depending on what the food menu is option, right? So as you can see, these parameters is not something that you would use in your build, but it's just, so we call it active choice reference parameter. So it just tells you something about the system. Perhaps it shows you a graphic, to see what's happening. Any question on this? I'm just wondering whether people really want to stay longer, or they are anxious to go for some drinks. I think probably if we discuss the reusing build artifacts, will probably take us to 7:45 to 8. 8? Do you guys want to stay? Is it
Another 10 more minutes.
Another 10 minutes?
I'll stay.
You want to stay for that? Okay. All right, so this is an important topic, especially when you're doing the type of analysis we're doing. And you will see in a minute why that is the case. We want to provide inputs for Jenkins builds, right? What is the typical way of doing it? When you're working with DevOps, Jenkins and DevOps, essentially there's hardly any user interaction on the user interface, right? You check in some code, and there is a whole bunch of support for interaction with the repository, with the code repository, right? All these repositories basically allow you to check the code out. This is your input, start your build, right? You compile that code, you run your tests. You're done, most of the time you throw all that stuff away. The next sort of build, the code that you just checked out is essentially a disposable artifact, right? If anything, you might keep the binary that you created, right, and store it in a binary object repository. But the input itself, most likely you don't care for, right? Well, the input is actually quite important in what we're doing. If you're doing any kind of bioinformatic analysis, right, it's almost like doing math, right? And somebody's saying, you remember in high school, right? You know, you've got to show the process. You just can't show the result, right? So that's what's happening here, both in terms of the reproducibility we need and what we need to track. We cannot throw that data away. In fact, that data is reusable. Basically, you upload a file, and it stays on the server. Now that file becomes the input for another part of the analysis. And the output from that part, which is now maybe QC data, it goes into some multi-parametric data analysis. So there's a continuous workflow, and artifacts are created at one stage from one job of Jenkins. They need to go into multiple other jobs, right? Jenkins is really not very well equipped to do that. So we have to kind of like work our way around. All right, so here's the typical structure of the so-called build folder after Jenkins is finished. Okay? So here is the job name. Here's a particular build that has a timestamp. And what you see under there is a few different things, such as the build artifacts that are in this archive folder, some metadata from the build that is essentially encapsulated in this build XML file, the console log that you would see when you're running, whatever you're writing out to the console, you see there, right? If you uploaded any data, any files, Jenkins generates a special folder called file parameters, and it stores the original data set there, right? But Jenkins itself does not use a database. All this data is up on the file system, right? So we need to be able to discover it, and we need to be able to reuse it, right? So we kind of want the functionality of a database, but we don't have a database. So what happens when you start Jenkins? When you start Jenkins, it goes through all of the job folders and all of the builds, and it reads these build XML files. And it creates an in-memory model of the parameters that you used, the entire, it has an object model in memory of every build you did, right? If you have hundreds or even thousands of builds, right, at some point that does not scale, right? And that's why most people throw away their builds, right? So that right now is a limitation because we do not throw away builds very easily. We keep them alive. Still, I would say that it's still a pretty robust model so far because I've been running Jenkins and I haven't thrown any build away for the last 4 or 5 years, and I have not seen any big performance hit. At the same time, we do not have thousands of jobs. Maybe we have few dozens, right? So maybe that's what it is, right? But once you have that model in memory, you can access it via the Jenkins Java API. So here's an example. You know, Cell Profiler is the software that does the image processing. And basically needs two pieces of input. It needs a image processing instructions, and it needs a list of the images that it will process. All right? So this is the input to our builds, and then essentially is going to output some multiparametric measurements. So in kind of more block diagram, this is the input, the build steps, and the output. So how do we get to choose the input that we want for a cell profiler build? Because basically what people will do is they will upload pipelines and they will generate from Jenkins image lists that are now stored as archived artifacts on the server. So how do we choose those to select and put them into cell profiler? Well, we've written some custom Java code, Groovy code, that runs as a scriptlet that allows us to return these job names that have the data we need in a particular format, job name, build number, okay? And therefore a user can select the data that they're interested in as a reference into a build. Now, it turns out that Jenkins has a similar parameter, they call it run type. So a run type is a built-in parameter in Jenkins that essentially puts a URL into your build environment that points to another build, right? And that's sort of the referential thing that it does. The problem with that is you don't have many options on how to select that reference. For example, sometimes the data that we have stops being compatible with a build because we made some changes. So we would like to say, you know what, past build 15, we cannot deal with this data. Or previous to build 15 we can, but after build 15 we can, right? So we would like to have a system of where we can filter these builds from these references from other things to ranges that we're interested in, or even filter them for parameters that exist in those builds. So this is where we wrote some of those things. This helper, so scriptlet. So for example, it allows us to put a variable called the search space, and it's a comma-separated list of jobs we're interested in, and then provide two parameters called the F and L for first and last of the numbers that we want to filter for. And basically then we plug that into the Active Choices plugin as a parameter. And so that gives us actually now a drop-down list with the pipelines and image lists we're interested in. Okay, so this is how we select those to go into the cell profiler. Okay, I will stop here. The other last two slides that I have are about our Biono open source project. I just want to mention that a lot of this wouldn't be possible without Bruno Kinoshita, who is a terrific collaborator and contributed to several open source projects. He's in New Zealand now, originally from Brazil. And he has developed several bioinformatic plugins for Jenkins, which you will find in the Biono site. Some are associated with genetic analysis, chemical structures, and so on. And that's it. So I think we're gonna, so this presentation has links to my GitHub, and also we put the presentation itself on GitHub, and then we can share it.
We can link it from the Meetup site,
Yep.
so in the notes,
Excellent.
or comments or whatnot.
Okay.
All right.
Thank you.